Hello, my dear students. Very good morning to all of you. This is Dr. Shankar Konda, Assistant Professor, Department of Chemistry, KJ Somaya College, Kopergaon. Today, we are going to discuss on ionic equilibrium of buffer solutions. In the last lecture, we are discussed about ionic common ion effect. So, in this lecture, we are going to learn buffer solutions. Here we can see the buffer solutions. It is an aqueous solution which resists the change in its pH value by the addition of small quantity of acid or base is called as buffer solutions. It means this is aqueous solution. It resists the change of its pH value by adding the small quantity of acid or a base is called as the buffer solutions. Simply, whose pH should not be changed on addition of appreciable amount of strong acids or a bases is called as the buffer solutions. Here we can see, for example, in the humans, if we have the blood itself a great example of a buffer solutions. For example, if you eat any acidic food, your blood never becomes acidic, or if you eat any basic food and your blood never becomes the basic solution. So therefore, blood itself, it maintains its resist whether you eat any acidic solutions or whether you eat any basic food. Itself, it maintains its pH becomes the neutral. So therefore, blood itself is a good buffer solution. Likewise, is a buffer solution, it's aqueous solution which resists the change in its pH value by the addition of small quantity of acid or base is called as the buffer solutions. Here we can see the buffer solutions are different. Buffer solutions are there. Buffer solutions of two types of buffer solutions. One is acidic buffer and second is the basic buffer. Here we can see the acidic buffers. We can see the acidic buffers, the pH value of the acidic buffers have the less than 7 and the pH of basic buffers having the greater the 7. Here we see the some of the images, the pH of 7, pH of 4, pH of 1.68 means pH of 12. It means that those of pH less than 7 they becomes the acidic buffer, and though greater than the 7 of the pH of those solutions becomes the basic buffers. Here, what is meant by acidic buffer? An acidic buffer can be prepared by the mixing of weak acid and its salt of strong base. See, this is very important. You have to remember, acidic buffer can be prepared by the mixing of weak acid. That is, for example, acetic acid and its salt of strong base. Again, the salt should be the same of acid. That is of salt of strong base. For example, sodium acetate in water. Here we can see acetic acid is a weak acid and the second salt of weak acid, that is sodium acetate, CH3CONA. Here this CH3CONA sodium acetate which is prepared by the weak acid and the strong base such as NaOH. So therefore, acidic buffer is it can be prepared by the mixing of weak acid, acetic acid and its salt of strong base, that is sodium acetate in water. It forms acetic acid plus sodium acetate gives the acidic buffer. The solutions are the remain the pH value less than 7. It means all the acidic buffer, those pH are less than 7, therefore those are the acidic buffer. Here second is the basic buffer. The basic buffer can be prepared by the mixing of weak base, that is very important, weak base and its salt of strong acid. For example, ammonium chloride in water. Here we can see the ammonium hydroxide. Ammonium hydroxide is a weak base and its corresponding salt we can see, that is salt of its strong acid, that is ammonium chloride, that is of ammonium hydroxide plus HCl if it is forms ammonium chloride solution. Here weak ammonium hydroxide weak base plus its salt of strong acid of ammonium chloride, it forms the basic buffer, and these solutions are maintained the pH value greater than the 7. So these are the two types of buffer solution. One is the acidic buffer and second is the basic buffer. Acidic buffers having the pH value less than 7 and the basic buffers having the pH value greater than the 7. Here we can see the pH buffer solution of pH 4, buffer solutions of pH 1.68, buffer solution of 7, and here buffer solution of 10. If some solution of pH equal to buffer solution of pH 10, it means that that is a basic buffer. Here acidic buffer, for example, buffer solution pH equal to 4, that becomes the acidic buffer. Likewise, there are acidic buffer and the basic buffers are there. Next, we can see the applications of buffer solution. This is very important where we have to use the buffer solutions. As I told, the best example, blood, it can be acts as a buffer solutions. Likewise, where we have the applications of the buffer solutions. The first, in the qualitative analysis of, that is in the inorganic qualitative analysis, where we can see the several cations are precipitated in basic medium and basic buffer is used. Here we can see in the qualitative analysis of inorganic mixture, where certain cations are precipitated only in the basic medium. For that purpose, we have to use the basic buffer. For example, the acetate buffer is used for anion mixture, that is removal of phosphate. Second, in the biochemical process, buffers can be used for the enzyme action. In the biochemical process, buffers can be used as the enzyme action. Next, in the pharmaceutical preparations, in the pharmaceutical industry, in the pharmaceuticals preparation, in the drug preparations, buffers are used for the preparation of some drugs and preserved by using the buffer solutions. Means the drugs are prepared and still they are preserved in a certain conditions using the buffer solution, maybe of acid or maybe of basic buffer. Next, in the pathological laboratories, this is very important. Buffers are used to perform the test. In most of the laboratory tests, most of the pathological laboratories, buffers are used to perform the test where the different tests can be taken. Next, in the soil chemistry, where the fertilizers at particular pH value absorbed in the soil controlled by using the buffers, where the which type of fertilizers are used, how they can be controlled, what type of pH of the soil is detected by using this soil chemistry, that is fertilizers at particular pH value absorbed by the soil controlled by using the buffer solutions. And finally, buffers are also used in the stabilizers as well as, very important, they can be used as the preservatives. So these are the some important applications of buffer solution. Here we can see it. So with this, we have studied what is the basic definition of buffer solutions, types of buffer solutions, and applications of buffer solutions. Okay. Here, thank you so much for watching this video, and thank you for once again to watch this video.